Okay, this is quiz 40. And to be able to do quiz 40, we need to remember a couple of logic rules. So from slide 48, we have the following. X, y bar plus y is equal to x or y. And then from De Morgan's laws, we have that x or y bar is x bar y bar, and x y bar is going to be x bar or y bar. Okay, so now let's come down here to this circuit, and let's just write out what y is. So the output y is going to be, we're going to OR two things together. It'll be a bar ANDed with C bar, or it will be B ANDed with C. So that comes directly by looking at the logic gates and reading that out. Of course, A bar, C bar is the same thing as ANDing this with B or B bar, C bar, and then we have A or A bar ANDed with BC. So we could write this as A bar, B, C bar, or A bar, B bar, C bar, or A, B, C, or A bar, B, C. So if we write out our function here, A, B, C, one. Then let's see. So A bar, B, C bar is going to be a 1 here. A bar, B bar, C bar is a 1 there. A, B, C is a 1 down here. A bar, B, C is a 1 here, and then we've got zeros everywhere else. Okay, so now we come down to our questions. If we wanted to just have A or B or C, what would we make Y? And you notice that if from this expression up here, that if A is equal to 1, then Y is just, Y is equal to just BC when A is equal to 1, because A bar is going to be 0. And so the other three terms in Y would give you 0. So when A is tied to 1, or in other words, when A is VCC, the maximum voltage applied to the circuit, then this circuit looks like, from the perspective of B and C, it looks like B ANDed with C. Now, we would expect, I guess we could also note that B and C, because of okay, so this second expression we might expect would be when A is equal to ground, or when A is equal to 0. And when A is equal to 0, what do we get? Y is equal to BC bar, or B bar C bar, or BC. And that's going to be B plus B bar, C bar, or BC, which of course is C bar or BC, since B or B bar is always equal to 1. And now this expression from, our expression up here is simply equal to C bar or B. Okay, and C bar or B this is going to be C bar or B bar bar. When we conjugate and then conjugate back, we get the same thing. So De Morgan's law tells us that this is going to be C B bar bar. And that is the expression here. So when A is equal to ground, G and D, then we get that expression. And notice also back here when we had C bar plus B, that's this expression here. So when A is equal to ground, we get B plus C bar. Now let's look what happens when we get when B is equal to 1. Going back up to our expression up here, when B is equal to 1, Y is equal to A bar C bar, or AC, or A bar C. So again, we can factor out the C here. We get A bar C bar, or A plus A bar times C, and that's going to be A bar C bar plus C. And now we can again go back and use that expression on slide 48, the y x y bar, to get that this expression then is going to be A bar or C. And so we look over here and A bar or C, this is when B is equal to VCC. And then by De Morgan's law, we get that this is going to be A bar or C bar bar, and that's going to be A C bar bar. So we can go back here and look for A C bar bar, and so that's also when B is equal to VCC. Okay, now when B is equal to 0, let's see what happens. Y is going to be equal to, so we go back to our original expression up here, and when B is equal to 0, we get A bar C bar from here, and that's it. So luckily that's one of our expressions. So this is when B is tied down to ground. And then De Morgan's law says that this is A bar C bar bar bar. And that's not De Morgan's law, that's just barring it twice. And then De Morgan's law says that this is going to be A or C bar, and that's this expression here. So when B is equal to ground, then Y is equal to A or C bar. Okay, now this next expression is a little bit tricky. So here we have, so remember that that y is equal to, or I guess let me just write up here at the top. So B XOR C, this is the same thing as B C bar or B bar C. That's what XOR means. So when B XOR C bar, that's going to be equal to B C bar or B bar C bar, like that. And that's going to be, we can now use De Morgan's law. Well, I guess maybe instead of doing that, let's go back and just say what is, so B XOR C, I guess if we draw a little diagram here, so this is B and C, and then this would be B XOR C bar. So when B is 0, 0, 0, 1, 1, 0, 1, 1. So B XOR C is going to be 1 when they're different. And so when we bar that, it's going to be 1 when they're the same. So we're going to have a 1 and a 1 and a 0 and a 0. Now if we look up here at just B and C, when these rules are when these rules hold. So when B and C is 0, 0, it's 1. When B and C, and down here it's 0, you see. So we want this one and not the other one. So we also see that when 0 and 1, when B and C are 0, 1, we get a 0. So we would want this guy. And so let's say, let me erase. We don't want that one, but we do. We want that to be true. We want that to be true. And then when B and C is 1, 0, we want it to be 0. So that's true, but not the other one. And then when it's 1 and 1, we want it to be 1. Okay, so now look at what's happening with A on these 4 cases. So if you notice that on these 4 cases, A is equal to A and B are equal in each of these 4 cases. So if A is equal to B, whatever B is, so if we tie A and B together, then this looks like B XOR C bar. All right. Now, how would we get Y is equal to A bar? Let's go back up to our original expression. So let's see, let me write it back down here. So Y is equal to A bar BC, or A bar B bar C bar, or A B C, or A bar B C. Okay, so we want now, what can we do to B and C so that Y is equal to A bar? So let's see, if from this expression, if we tied both B and C high, then this expression would be equal to A bar. If we tie them both high, that'll be 0, but this will also be high, so we can't do that. And B and C, yeah, so these expressions would all be true. So what if we were to tie, let's see, did I copy this down right? A bar, oh, this should have been A bar B C bar, A bar B bar C bar A B C. Okay, so now let's let's go back and look at this. Okay, so if we were to tie B high and C low, okay, so that this expression was A bar, that would make, when B is high, that makes this whole expression 0. C bar would be low, so this expression would be all 0. And then this expression would also be 0. So if we made B VCC and we make C ground, then notice that that this expression is always equal to 0. This expression is always equal to, it's always equal to 0 because B bar is always equal to ground. And then this expression is always 0 because C is always equal to ground. And this expression is always 0 because C is equal to ground. So this is a way in which if we tie B to VCC and C to ground, then this circuit looks like just nodding A. And what if we wanted to make this expression equal to B? Let me just go back and erase all this thing. So again, we want it to be equal to B. So let's just do a little bit of manipulation here. This is going to be equal to, since we have a B, let's just pull out B. So B is going to be A bar C bar, or A bar the second expression is not true. So, or AC or A bar C. So those are those three expressions. And then of course we've got B bar and A bar, C bar. So let's see, if we were to make for example, if we were to do something that's alternate. So in other words, if A were high and C were low, then that expression is always 1. This expression would be 0. That would be 0, but when we OR them all together, we'll have a 1. But that expression is 0. So we could either make A 0 and C 1, or A 1. Let's see. No, it looks like looks like that's the only thing that we can do, because if we make A equal to 1, then this is 0. So if we make A 0 and C 1, then this expression here is always is equal to 1, and this will be equal to 0, this will be equal to 0, and this whole term is equal to 0. So we get that this is equal to B. So we make A, we tie it to ground, and tie C to VCC, and this circuit acts, Y does whatever B does. Okay, so that is homework or quiz number 40.